All right, so we've seen the barrier, and I have a bit of a secret to tell you, and that is that all of the other synchronization primitives we're going to take a look at, they are all just like the barrier. In fact, all these primitives we're going to look at have this very similar idea of having some sort of internal counter and then waiting for that counter to run out. And sometimes, yes, they do reset the counter. So now we're going to take a look at exactly this kind of construct, which is called a countdown event. So let me show you an example. Let's suppose that we have 5 tasks that are doing some sort of work, and we want to continue, we want to execute some 6th task only when all of the tasks are finished. Now we can certainly do it using task.continue when all, but we're going to do it using a synchronization primitive instead, and specifically the countdown event. So let me make one. So let's have countdown event CTE equals new countdown event. Now we're going to have a certain number of tasks in this example. I'll have them as private static int task count with a value of 5. So I'll put that in here. And the idea is very simple. We have a countdown, and the idea is that we're going to basically inform somebody who's listening to the countdown event as the countdown is actually counting down. Now the difference between countdown event and the barrier that we saw previously is very important. Remember, in the barrier we had a method called signal and wait. Now we don't have this for the countdown event. Instead, what happens is the signal and the wait are separate methods. So here is how it would look. Let's imagine that we have a bunch of tasks. So I'll have var task equals, actually we're not even going to wait on the tasks. So maybe we won't have a list of them. Let's just make them. So I'll have an I going from 0 to task count. And in here, I'll spawn a task. So I'll say task.factory.start new. And in this case, all I'm going to do is just, once again, right line a bit. Let's actually do a random sleep. So I'll add a static random equals new random here. And then we'll do some random sleep in here. So after outputting something, so I'll right line, for example, that we are entering task, and then let's do the task ID, so task current ID here, and then I'll do a thread.sleep from 0 to 3 seconds, so random.next 3000, and then I'm going to signal on the event. So CTE.signal. What this means, you'll notice that we had signal and wait as a single function. Now we're just doing the signal. So now all we're doing is we're essentially taking the countdown by 1. So if it was originally 5, it's now down to 4. And when it reaches 0, that's when any waits on this countdown event will be released, and you could execute something. So we'll do CTE signal, and we'll right line that we're exiting the tasks. So exiting task dot current ID, like so. So that's our tasks. There's going to be a lot of them. And then let's suppose that we have yet another task that we want to complete only when all of these tasks are complete, meaning the countdown has run out. Now we keep kind of decreasing the countdown here by doing the signal part. So at some point we want to do a wait on it. So we'll have some final task, which is once again task.factory.start new. So in this case, we're going to right line the fact that we're waiting for other tasks to complete in, and then let's have our task ID. So let's have task.current ID, and then we're going to CT.wait. So we're going to wait until the countdown reaches 0. And that's when you actually get to execute whatever is after. So this is a blocking invocation. It's basically going to block this entire thread until the countdown reaches 0. And the only way it will reach 0 if all the threads actually signal. So we're going to have to wait for every single one of those tasks to complete. And then we're going to right line all tasks completed. And that's exactly the event that I'm going to wait on. So let's execute this. Let's see what we actually get. And as you can see, we're sort of in the process of executing tasks. At some point, we do start waiting for all the tasks to be complete. So we do start that task with task ID 6, but it cannot complete until every single thread is done. But once every single thread has signaled, then we can print that all the tasks have completed. So as you can see, it's a setup which is almost identical to the barrier, with the difference that you have, instead of signal and wait, you have signal where you can just change the counter, and at some other location you can wait on that counter being 0, and if it is, then you get to execute whatever is